So, hi Manoj, can you please give your brief introduction about yourself?
So myself, assistant professor in chemistry department of Trident Academy of Creative Technology, which is situated near Patia Bhubaneswar Infosys campus. Can you hear my voice? My
Yeah,
voice
yeah.
is audible.
Yes, yes.
And yes, so that I am staying in Bhubaneswar, and myself assistant professor in chemistry.
Okay, thank you.
Trident Academy of Creative. Do you know Trident Academy of Creative Technology?
I don't know Trident Academy, but I know that Trident is a company which manufactures paper and all. Is it linked with
No, no,
that?
this is another.
Okay, okay.
No, 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 not at all. Not
Okay.
at all, because this is a purely educational institution, and that is separate thing. So which is situated near Infosys campus and Patia Square in Bhubaneswar.
Okay,
Okay, thank you, madam.
thank you. Okay, I think there is no one to join now, so I'll start with the questions. Let me first share my screen.
Yes, yes, yeah, madam.
So, is my screen visible?
Yes, madam.
Okay, so good afternoon.
Hello. Now it is visible.
So, good afternoon. I'm a TA for the course Environmental Chemistry. Welcome to the problem solving session for the week 5 materials. The course instructor is Professor Bhanu Prakash Velanki from Department of Civil Engineering, IIT Roorkee. My name is Asma Parveen. I am a PhD scholar in Civil Engineering Department, IIT Kanpur. So, what we will see, I will give a brief introduction, just 2 minute introduction about what was taught in week 5. So, week 5 lectures was about finding the dominance of the species depending upon the pH. We saw graphs, how to find the graph for a particular acid depending upon the concentration and pH. Then we saw numericals based on these on how to find the pH of any system using visual mintic. And week 5 was all about finding the pH and the dominant species relevant to the given pH. So what we are going to do is we will see the previous year questions based on this material. I will request to that I will show you the question. I will give you a hint, and then I will request you to just try to solve the question, and then we will see how to solve the question using visual mintic, and if the question can be solved numerically, then we can also see that. So let's move to the first question. So the first question is, in the log C versus pH diagram given below, various points from 1 to 5 are given. Which one of them donate the point where pH equals to pKa for the monoprotic acid system? So we have been given a log C pH graph, and we have to find out of the given 5 points, 1, 2, 3, 4 and 5, which point shows that pH equals to pKa. So it is a straightforward question. So I will give you 2 minutes to think about this and just write your answer in the chat box. So
Madam, three question point three. Am I right? Or
yes, point 3 is the points where pH equals to pKa. Can you please give the reason why is it so?
So because here the proteinated the that is HSC now start to decrease, the concentration decrease, and whereas the pH gradually increases, and in that case, in that point, so AC deprotonated will start from that point.
But
Concentration.
yeah. But at pH equals to pK, both the protonated and the deprotonated form exist at equal concentration. That is, the
Yeah, yeah,
concentration
yeah,
of
madam. Yeah,
HSC will be equal to the
yeah,
deprotonated
yeah,
form.
yeah.
So let's move to the next question. So the question is, which of the conditions given below are true for the log C versus pH diagram given in question 1? So we have to refer to the log C pH diagram given in the previous question, and this question has multiple correct options. So 5 options are given, and based on the pH pK relation, we have to find out which of these equations are correct. So it is a quite lengthy question if you try to solve from the beginning. But I would recommend to just to not learn these equations. We can derive these equations if we know what is pH and what is pK, and we can find out the trend. So I will give you 5 minutes to find out which of the options are correct.
Madam, just now I'm telling you the answer. I'm not sure, but the answer may be B. The C, D, and E. Am I right or not?
No, C, D, and E are not the correct answers. So please try to solve the question. Let's start with the case. We will have 3 cases when pH will be less than pKa, pH equals to pKa, and pH greater than pKa. Let's first find the equation for pH less than pKa. So I will give you 5 minutes. Please try to find the relation between the concentration of the deprotonated and protonated form and the pH. So let's see how to find out these relations. So we have three cases. First one is when pH less than pKa, and second will be pH equals to pKa, and the third will be pH greater than pKa. So we will see when pH is less than pKa. So we know that we can write the concentration of overall acid as summation of the as sum of the concentration of deprotonated form and the protonated form, and we can write deprotonated form in the terms of alpha 180 so we know that alpha 1 is given as concentration of H plus upon concentration of H plus Ka, and 80 is, let's assume it to be Ct, that is the total concentration. So let's not assume it's Ct, let it be 80 because options are given in term of 80, so it will be 80. And similarly we can find out the concentration of deprotonated form as Ka upon H plus Ka into 80. So we have two equations, equation 1 and 2. So let's see. So from 1, when pH will be less than pKa, it means that the concentration of H plus will be greater than the Ka value. So we have Ha as H plus upon H plus Ka into 80. Since when pH is less than pKa, concentration of H plus is much greater than Ka. So we can write it in the form of H plus upon H plus into 80. H plus will cancel out. And we have Ha as 80, that is we can write in terms of log Ha equals to log 80. So I am using the square bracket which shows concentration. We are not considering the species because we are assuming that the system is diluted. And we can write the from 2. We can write that concentration of A minus is Ka upon H plus Ka into 80, and since pH is less than pK, H plus is much greater than Ka, we can write it in the form of Ka upon H plus 80. We will take log on both sides. We will get log A minus equals to log Ka minus log H plus log of 80, which is log A minus equals to log Ka plus pH plus log 80. So let's see. So the first option is not correct. Second option is correct. So B. Let's find out for pH greater than. Let's find out when pH is equals to pK. Then we have HAC equals to log A minus. Since we know HA will give H plus and A minus, and we will have some Ka, and Ka is given as H plus A minus to the ratio of HA. If we take, and we know we will take log of both sides, it will give log H plus log of A minus log HAC. Sorry, HA. And we have pH equals to pK, that is log Ka and log H plus will cancel out, and we will get finally log HA equals to log A minus. So, and the third case, when pH greater than pK, it means that concentration of H plus will be much less than Ka. So let's see, we have HA as H plus upon H plus Ka into At. We have pH greater than pK, and that means H plus will be less than Ka, so we can write finally it as H plus upon Ka into At. So if you take log on both sides, so we will have log HA equals to log H plus log of At plus log, minus log Ka, which will be equivalent to log At minus pH plus pK, or we can leave it like minus log Ka. Similarly, we will find the relation for, okay, I have not added a page. So similarly, we can find here for A minus, which will be equals to K upon H plus K into At. And since K is greater than H plus, so here we will have At. That is, deprotonated form will be equal to the overall concentration of the acid. That is log A minus equal to log At. So let's see what are the correct options. So B is the correct option. C is also the correct option. And I think E is the correct option. So B, C, E. So overall E is the correct option. So let's move to the next question. So we have, while preparing the log C pH graph for a solution at equilibrium with ammonium plus ammonium at 10 raised to minus 4 molar, pK is given. The correct linear equation for ammonia when pH less than pK is, we have to provide all the correct options, that is multiple select options. We have to select the options which are correct. So it is also similar to the previous question, only we have given a different acid, NH4 plus. So I'll give you 5 minutes to just find out what are the correct options.
So, madam, I have in doubt in that questions. So,
Yeah.
whenever you go solve this such type of questions, so we have to follow the equations of pH and log and all these things.
Sorry, can you please repeat
Hello.
the question?
So, whenever you go for this solve this such type of questions, so we have to follow the equations which is given, the log pH and log pK. These equations we have to follow.
Yes. Whenever first these are for log C pH graphs, and to find out these equations, we have to follow the protocol that we have to find the species, components, then total concentration of the acid, then how alpha 1, alpha 2, we can denote each species in the terms of alpha 1 and alpha 2, and then taking the condition when pH less than pK, pH greater than pK, we will find out these equations.
No, my question is,
Yes,
we need to sort out on each step. That is my question.
your voice,
Now
can you
only
please
we have
type
to find
your
out a
question in the
particular question.
chat box, because your voice is breaking.
Okay, I'm okay. Okay, this is network problem, madam. Mm. Okay, I'm trying to do it. Madam, the correct option is B. Answer B. Hello.
Yes, but B is not the correct option.
Madam, correct option is B. B.
No, B is not the correct option. So let's see. So we have been given ammonium, which will dissociate into ammonia aqueous, will give 1H plus, and K is 10 raised power minus 9.24. So we can write NH3 as Ka upon H plus plus Ka Ct. And we can write NH4 plus as H plus upon H plus plus K into Ct. This is alpha 0, alpha naught, and this is alpha 1. So we have to find out the case when pH is less than pKa. It means concentration of H plus will be greater than Ka. So we have NH3 as K upon H plus plus Ka into Ct. So let's move to the next one. Now since pH is less than pK, concentration of H plus will be greater than Ka. Like, so we can write the overall denominator as Ka upon H plus Ct. So by taking log on both sides, we will have log NH3 equals to log Ka plus log Ct minus log H plus. So in the question we have been given that the overall concentration Ct is 10 raised to power minus 4 m. So we will have log K, that is log 10 raised to power minus 9.24 plus log 10 raised to power minus 4 plus pH. So we will get pH minus 13.24. But we have to find out in PNH3. So we have got the relation for log NH3. So let me add a slide. So we got the relation that log NH3 is equals to pH minus 13.24, and we have to find the relation between P NH3. So we will take my negative both sides, and we will have 13.24 minus pH. So minus log NH3 will be PNH3 equals to 13.24 minus pH. I think this is option A. So A is the correct option, that PNH3 equals to 13.24 minus pH. So I hope now this question is clear. So if you have any doubt, you can ask in between also.
madam, जो log the value of log 10 to the power minus 9.3224.
Yeah.
So during the examination, they will provide log table. Now we have to just assume it to find out the values.
No,
Log
no,
10
like
1,
so log
well, value
10
of this one log
or anything is equal to that value only.
only, right?
Yeah, and
Right.
also calculators, I think calculators will be allowed in the end exam.
Okay,
Or
okay.
if
That
calculator
is
will
it.
not be allowed, there will be some digital calculator available, so we can do the calculation there also.
Okay, okay. Okay. And that was the okay, okay. I'm clear. Now I'm clear.
Yeah. Let's move to the next question. So this question we have to find the alkalinity. 500 ml water sample is collected, out of which 200 ml is titrated with 0.03 normal sulfuric acid to an end point of pH 4.5. Titration consumes 50 ml of sulfuric acid. The total alkalinity as CaCO3 is, we have to find out the alkalinity, and we have been given that we are taking 200 sample and we are titrating with some acid to the end point of 4.5 pH, and some amount of acid is consumed and we have to find out the alkalinity. So this question is based on equivalence point that N1V1 equals to N2V2. So I'll give you 5 minutes to just do the calculation and find the correct answer.
Total alkalinity is with this one minus this one is equal to 93.7. Madam, 93.75 gram per liter.
We have to find in the terms of CaCO3. So have you changed in the terms of CaCO3?
CaCO3. This is also on the basis of the value. I found the value of total alkalinity is equal to 93.75.
No, no. C is not the correct answer. Let's see.
The minus this one and again this titration of this one and again minus 1 to
So
93,000.
the sample volume is 200 ml, not 500 ml.
200 LA. If it is 200, then P divided by this one.
So let's see how to solve this question. So at end point, so we have volume of sample taken as 200 ml. We have given the volume of titrant as 50 ml and titrant is 0.03 normal H2SO4. So at the end point we will have the relation N1 V1 equals to N2 V2.
Yes, N1, N2, V2,
Yeah.
V2, H2C.
So we have been
H2C.
given N2 V2 for acid, the normality of acid and the volume consumed, and we have been also given the volume of sample we have taken. So we will calculate
Mm.
N1 as N2 is 0.03, volume is 50 upon NV1 is 200.
200. And then you can find out easily.
So it is 0.0075 normal. So we just have to do the conversion next. Like we know normality is given as
Gram per equivalent weight. Normality is equal to.
it is number of gram per equivalent which is given by weight of
Uh,
the sample divided by equivalent weight into volume. So we have to find it out in terms, we have to find the calcium total alkalinity in milligrams per liter. So we can take out weight by volume equals to normality into equivalent weight. So we have been given the normality as 0.0075 and for calcium carbonate equivalent weight will be the molecular weight of calcium carbonate will be 100 divided by 2 because charge is 2, so it will be 50. So
mm,
into 50, so I think by multiplying this we are getting 0.375 grams per liter. That
oh, it
is total total alkalinity is
right, right.
375 milligrams per liter.
Right, okay. B, option is B, right.
So let's
Mm.
go to the next question. So it is given, consider a closed system prepared with initial concentration of sodium phosphate, sodium biphosphate, sodium NaH2PO4 and phosphoric acid. The correct equation for total H is, so we have to find the equation for denoting the total concentration of H plus in the system. So we are adding
Mm.
four compounds in the system. So I think this question is based on the week 4 material. So
Ah,
please,
yes, yes.
please try to solve this question. Just I will give you 5 minutes. Then we will see how to solve this question.
Okay, madam. Okay, madam. The answer will be HTH plus PW minus. C. Madam, please explain it because it is very difficult question.
So let's follow the steps to solve question like this. So first we'll find out the species in the system, then components, followed by the formation equation, and then we will make the table, and then we can find out the concentration of the different components. So let's see what we have been given. We are adding Na3PO4s 1 molar, so let's first write the species and components in the system. So species, it will be H plus OH minus. We are adding sodium, all the species of phosphoric acid. So these are the species which will be present at equilibrium. So let's write the components, the building block for any reaction. So components will be H plus, Na plus, and the most deprotonated form of the phosphate, that is PO4 3 minus. So let's write the formation equations. So we will have Na plus, it will come out from Na plus only. H plus will be equal to H plus, and we can write OH minus as H2O minus H plus, because we know that H2O dissociates in H plus and OH minus. And we can write the equation for H3PO4 aqueous, which will be H plus plus H2PO4 minus, and again H2PO4 minus, it will give 1H plus, and again HPO4 2 minus, it will give 1H plus and form PO4 3 minus. So let's form the table here only. So in the horizontal direction we will write all the components, that is H plus, Na plus and PO4 3 minus. And we will write the species is H plus, OH minus, Na plus, H3PO4 aqueous, H2PO4 minus, HPO4 2 minus, and PO4 3 minus. I think we will not be able to add the compounds which are being added. So let's move to the next slide. Let me use the eraser. So let's make the tableau here. So we have H plus, Na plus, and PO4 3 minus as the components. Species are H plus, OH minus, Na plus, H3PO4, H2PO4 minus, HPO4 2 minus, and PO4 3 minus. And components which we are compounds which we are adding is Na3PO4, Na2, HPO4. We are adding NaH2PO4, and lastly we are adding phosphoric acid H3PO4. So H plus will give us 1H plus 0 NO plus and 0 PO4 3 minus. For OH minus, 1H plus is consumed. It will give 0 Na plus and PO4 3 minus. Similarly for Na plus, and H3PO4 PO4 aqueous, it will give us 3H plus, 0 NO plus and 1 PO4 3 minus. H2PO4 minus will give us 2H plus, 0 Na plus and 1 PO4 3 minus. Similarly for HPO4 minus, 1H plus, 0 NO plus and 1 phosphate, and for phosphate 0H plus, 0 Na plus, and it will have 1 PO4 3 minus. So from Na3PO4 we have 0H plus, it will give 3 Na plus and 1 phosphate. Na2HPO4 will give us 1H plus, 2 Na plus and 1 phosphate. NaH2PO4 will give us 2H plus, 1 Na and 1 phosphate, and H3PO4 will give us 3H plus, 0 Na plus and 1 phosphate. So let's write the H total here. So we can write H total equals to H plus minus OH minus plus 3H3PO4 to H2PO4 minus and so on. So H plus will be equal to concentration of H plus minus OH minus plus 3H3PO4, 3 times of this, plus 2H2PO4 minus plus HPO4 2 minus, and all these will be equal to Na2HPO4 plus 2 times of NaH2PO4 and 3 times of H3PO4. So, but the options are given in terms of alpha 1, alpha naught and alpha 2. So, from here we can write H total as H plus. We can write OH minus in the terms of Kw upon H plus, because we know H2O dissociates as H plus plus OH minus, and Kw is H plus OH minus. So from here we can write OH minus equals to Kw by H plus. So again we have to write 3H3PO4. So we know that the most deprotonated form can be denoted in the form of alpha naught. So it will be 3 alpha naught. Next we will have 2 alpha 1, alpha 2. That's it. And we will multiply it with total phosphate. So I think this is the equation, and alpha naught equals to H3PO4 by total phosphate. Alpha 1 will be equals to H2PO4 minus by total phosphate concentration, and alpha 2 will be equals to HPO4 2 minus upon total phosphate concentration. So let's see. Let me write it neatly here. So let's see what are the options given. So first option will be H plus equals to H plus minus. So A is the correct option. And also the HT total concentration of H plus is given in the terms of the compounds added. So we have find out here also that, let's write in the next slide. Also H total is equals to Na2HPO4 plus 2 times of NaH2PO4 and 3 times of H3PO4. So the correct options are A and D. So correct options are A and D.
From here,
Yes.
so whenever you go for the tabular, so at that time we have to choose only the component. On the basis of the component, you make the table.
Yes, on the basis of components and species present in the system.
Achha, achha. So alpha 1 and alpha 2, we have to put in place of the value of H3PO4 and PO4 divided by PO4.
No, no. We write alpha 1. If you write alpha naught, it is the ratio between H3PO4, that is most deprotonated form, and the total acid concentration. Similarly,
Achha,
alpha
achha.
1 is uh, HPO4, sorry, H2PO4 minus and total concentration. So if we want to replace H3PO4, then we will write alpha naught into PO4, total concentration
No.
of the acid. That's why I have multiplied it all with PO4 total.
Oh, right. This is right. But the question, whenever the question asks you find the pH, so how we can find out the pH value? Sometime the question is asks you,
Yes.
so the pH of the solution after achieving the equilibrium. So how we can find out? So in that case, we have to use beam into equation.
So we can solve by hand, by manually, we can solve cubic equation. Is it? So if the
Okay,
system is like that, if this equation is forming some cubic equation, then we can easily solve it and find out the pH.
okay.
Am I
So
right?
say this value on the
But
basis
if,
of value total H, you can find out a pH, nahi?
yes, if we can find out the total H plus concentration from all the compounds which we are adding, we will
Okay,
equate with it and then we will find out. But since this system we cannot solve manually, because in the alpha naught, in the denominator, we will have a cubic equation. It will be H plus cube, and it will be in the terms of H cube and H square and K1, K2 and K3.
uh-huh.
So to solve
Achha, achha.
such a complicated system, we will have to use the visual mintek. And if the
Achha, achha.
system is for some monoprotic acid or diprotic acid, then we can solve manually.
Okay, okay, okay. Thank you.
Okay, let's move to the next question. So again, I think the question is same, and we have been asked to find out the total Na concentration. So I have shown you the table. So easily you can find out the Na concentration. So I'll give you 5 minutes. So just find out the total concentration of Na.
Total concentration of sodium is equal to 7, or say I think 6.
No, 6 is not the correct answer.
So the on the sir, madam, how we can calculate the total concentration on the basis of the table?
So this is the table.
Yes, yes.
So from the second
Here
column,
is one.
we can find out
mm,
how many moles of sodium each compound is giving.
One. Here is one. Here is 5 6 total. After this underline, there is sodium sulfate is given. Here is H2. There's 3 2
Sodium
1.
sodium sulfate is not present in the system.
Okay, so that is one.
So we can write that Na plus is only equals to Na plus. It is given. It is not combining with any H plus or other species. So it is remaining as Na plus only in the system. And from these compounds, we can find the total concentration of Na plus. From like we are adding 4 compounds. So first compound is sodium phosphate. Each sodium phosphate will give us 3 moles of sodium and 1 mole of phosphate. Is it? So from here we will get 3 moles of sodium, and from the second compound Na2HPO4 we will get 2 moles of sodium, and
Yes,
from
yes,
third we
right,
will
right,
get 1 mole of sodium. So overall it is 3 plus 2 5 plus 1 6.
right, right. So because I added this one upper one, that is sodium. That is wrong.
And
Yes, yes. Okay, okay, right. Six. Answer is six. Hmm. Answer is six.
sorry, but we have to multiply with the concentration of the compound which we are adding. Like this, if we are adding 1 molar of this compound, then it will give 3 molars of sodium. But we have to see in the question how many moles or molar of each compound we are adding. So these 3 2
Oh,
1 and giving the coefficients of how many sodium will be released by each compound. So let's see what is the concentration of each compound which we are adding.
oh,
So we are adding 1 molar of Na3PO4.
yes. Right, right, right. This is a question is complicated.
And we are adding H3PO4, but it will not give any sodium. So we can write total Na as 1 into Na3PO4. It is giving us 3 moles of sodium,
Oh,
plus
right, right,
we are adding 2 molar of Na2HPO4 and it is giving us 2 moles of sodium, plus we are adding
right,
3 molar of this compound and it is giving 1 mole of sodium. So overall it is 4 and 6 10 molars. So total Na is 10 molars. So A is the correct answer here.
right, right.
Okay, let's move to the
Madam,
next question. Yeah,
madam,
yeah.
madam, just a minute. Just show the slides. Ah, right, right. So I'm writing. This is
See,
Na2.
if you're writing, that is a good thing, but all these video and even the slides are available on the NPTEL portal.
Okay,
You can refer there also.
okay.
If you're
Thank you,
writing,
madam.
I will wait for 1 or 2 minutes.
Okay, proceed, madam, proceed.
Okay, the question is for H3PO4. We have given the pK values for this acid, and we have to
Hmm.
find out the correct order of predominance of the species for the different pH values given. So we have to find out of the 4 species given, which of these species will be dominant at pH 2, 5, 8, 11 and 13. Again, we can find
Hmm.
out from log C pH. If we have the log C pH for H3PO4, by simply looking at the pH, we can find out which species is dominant. But since the log C pH is not given, we have to follow the equations, like we have to find out the cases when pH will be less than pK, and then we have to find out the concentration of each species, and then we have to consider, like, if pH is less than pK, we have to eliminate H plus or Ka depending upon the case, and then we will come out with the dominating species. So it is a bit lengthy question. So I'll give you 3 minutes to find out which of the species will be dominant at pH 2. We will proceed one by one. So let's first find for pH 2. So let's see how to solve this question. Actually, without doing any calculation, we can say which of the species will be dominant at the given pH. So we know that the dominance of the species depend upon the pKa value. So let's see. We have been given H3PO4. So it will give us 1H plus H2PO4 minus, and the pKa, first value of pKa is 2.15. It means at pH less than 2.15, the protonated form will be dominant, and pH greater than 2.15, deprotonated form will be dominant. So at pH 2, H3PO4 will be the dominant species. So we can also do by calculation like we have done in the first and second question, I guess, where we have find out for pH less than pKa. So here we have been given 2 and the pKa one is 2.15. So first is, we have been given it that pH is less than pKa, which means H plus will be greater than Ka1. So from this reaction, we can write Ka1 equals to H plus into H2PO4 minus upon H3PO4. So let's write in the terms of H3PO4 upon H2PO4 minus. It will be equals to H plus upon Ka1. So we have been given that pH is 2 and pKa1 is 2.15. That is pH is less than pK, it means H plus is greater than K and Ka1. So this relation will be greater than 1. So from this we can say that at pH 2, H3PO4 concentration will be greater than H2PO4 minus. So at pH 2, H3PO4 is the dominant species. Let's move to the next pH, which is pH 5. And we can see that pH 5 is greater than pKa1, but it is less than pKa2. So let's see which will be the dominant species. So second we have been given pH equals to 5, which is greater than pK1, but it is less than pKa2 value. So after forming H2PO4 minus, it will give us 1H plus along with HPO4 2 minus, and Ka value is, I think it was 7 point something, 7.2. So we will have Ka2 equals to H plus HPO4 2 minus upon H2PO4 minus. So let's write in the term of H2PO4 minus upon HPO4 2 minus, which will be equal to H plus upon Ka2. So we have been given that pH 5 is less than pKa2. pH is less than pKa2. So it means that H plus concentration will be greater than Ka2. So it means this equation will be relation will be greater than 1. So we can find out that H2PO4 minus will be greater than HPO4 2 minus at pH 5. So at pH 5, H2PO4 minus is the dominant species. So let's see at the what is the third pH given. So we have to find out at pH 8 and pH 11. So pH 8 is greater than pKa2, but it is less than, pH is greater than pKa2, but it is less than pKa3. Similarly, we can write that HPO4 minus will dissociate in H plus and PO4 3 minus, and we can write like that Ka3 will be H plus PO4 3 minus upon HPO4 minus, and we can write the relation in the terms of HPO4 minus upon PO4 3 minus will be equal to H plus by Ka3. We have been given pH 8, which is less than Ka3. It means H plus will be greater than Ka3. It means this relation will be greater than 1. So HPO4 minus will be greater than PO4 3 minus at pH 8. So the last pH is given. We have to find at pH 11 and pKa3 value is 12.35. Let me add a slide. So we have find out the dominant species at pH 2, 5, 8. Next we have to find out at 11. Also we have used that pH is less than pKa3. We can use the relation that pH is greater than pKa2. That's why there will be relation between HPO4 minus and PO3 minus. H2PO4 minus will not be in the dominant form in the pH 8. Let's see, we have been given pH is equal to 12 and we have that Ka3 is 10 raised power minus 12.35. So we have been find out that when pH is less than Ka3, HPO4 2 minus will be dominant form. And finally we have to find out at pH 13. So we can write Ka3 in the terms of H plus PO4 3 minus and HPO4 2 minus. So let's arrange this HPO4 2 minus upon PO4 3 minus will be equal to H plus upon Ka3. Sorry. And we have been given that pH is equal to 13, that is pH is greater than pKa3. So H plus concentration will be less than Ka3. So it means this relation is less than 1. So HPO4 2 minus will be less than PO4 3 minus, or we can write that concentration of PO4 3 minus will be greater than HPO4 2 minus. So at pH 13, PO4 3 minus is the dominant form. At pH 12, HPO4 2 minus is the dominant form. So let's see. We have find out that at pH 2, H3PO4 minus H3PO4 is the dominant form. At pH 5, H2PO4 minus is the dominant form. At pH 8, HPO4 2 minus is the dominant form, and at pH 11 also HPO4 2 minus is the dominant form, and at pH 13 phosphate that is PO4 3 minus is the dominant form. So correct answer is B. So I hope this question is clear. So if you have any doubt you can ask, or else we can move to the next question.
Madam, any shortcut method to find out the answer of these questions? Any shortcut methods?
So you can just see the pK value and then you can say, like we know now that at pK value H plus is released and the acid goes from the protonated to the deprotonated form. And we know that H3PO3 that is phosphoric acid will have 4 species. So let me
Right.
to the P along the
Next.
pH graph.
Okay.
So if we have, so I don't remember the accurate graph, but let me try. This will be the pK1. I don't remember the graph for this. Let me share the screen. Just wait for 2 minutes. I will share my screen. So this is the log C pH graph for the phosphoric acid. So we can see that we have been given pH 2 and pKa1 is 2.15. So red line that shows H3PO4 is the dominant form.
Yes.
And as the second pH is 5, which shows that H2PO4 minus is the dominant form. And again at pH 8, HPO4 2 minus is the dominant form. Also at pH 11. And from this graph, we can see that at pH 13, PO4 3 2 minus is PO4 3 minus is the dominant form.
Right, right.
So from this graph, we get the essence that as we move from one pKa value to the next pKa value, one H plus is liberated and it form and the protonated form is going towards the deprotonated form.
Right, right. Okay.
So you can see like if we have been given the pH is less than pKa1, so the acid has not given any H plus, it will be in its most protonated form, that will be H3PO4. And suppose
Right.
the pH is given as 7 and the pKa1 value, sorry, pKa2 will be it is 7.2.
Okay.
So we know that we have been given pH 7 and pKa2 is 7.2. So until pH 7, I don't know why my voice is repeating.
Mm.
H2PO4 minus will be the dominant form, because as soon as the pH goes to near to pKa value, then H plus will be liberated and it will convert to the deprotonated form.
Right, right.
So depending upon the pKa values and what pH is given, we can find out which will be the dominant form without doing any calculation.
Okay. Mm. Okay.
Okay, let's. So we will see two more questions are left.
Yes.
So the question is, a solution prepared with initial concentration of sodium bicarbonate and sodium carbonate are put into a closed system and the system is allowed to equilibrate. pH is X now if the system is open and allowed to equilibrate with the atmosphere having partial pressure of CO2 as this ATM, then the difference between pH of the open and closed system is. So we have been given two systems. One system is closed and the same system is now open. We have to find out the difference of pH between the closed and open system. So
Yes, yes.
we can solve this question directly by putting the value of the components in Visual Mintek. Let's see. I hope you have installed Visual Mintek.
So, madam, the visual maintain allowed to in is it allowed to in examination? No.
Yes, yes, it is a free software.
Okay.
You just
It
have
is
to
allowed.
yeah,
It is
it is
allowed to
allowed.
examine.
If you will just write Visual Mintek 3.1 is the latest version in the Google. It will give you the link to download the software. It is a free software for everyone. It runs on Windows.
Okay.
So as I can see that the assignment, many of those assignment questions are given to solve based on the Visual Mintek. So I'll request you to please download it, and it is very easy to calculate the pH, to plot log CPS graphs and do lot of things in the Visual Mintek. So let's see. So I have run the software and I have added the screenshot. So do you want me to rerun these question in the software, or I can use the screenshots to explain the question?
If you use the screenshot, so it is better for us, I think, because if you use this software, they quick give the answer, but it is very for understanding point of view, it will be problem. But if you use the screenshot, that is better for us.
So do you know how to use the software Visual Mentor?
Ah, yes, I know it.
Okay. Then then fine. I will just show you the screenshot of what are the components which I added and what was the final answer.
Yes, 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 ma'am.
So in the question, we have been given that NaHCO3 is 1 millimolars, Na2CO3 is 2 millimolars. So we will write the mass balance for our components. The components for this system will be H plus, Na plus, and CO3 2 minus. So first write the total Na. It will be equal to concentration of NaHCO3 initial plus 2 times Na2CO3, which is 1 plus 2 into 2, that is 5 millimolars. Next we will write the mass balance for H plus, and H total is equal to NaHCO3, that is 1 millimolars, and carbonate CO3 to my carbonate total will be equal to 1 time of NaHCO3 and again 1 time of Na2CO3 initial, that will be 1 plus 2, that is 3 millimolars. So we will just put the concentration of these components Na plus, H plus and carbonate in the Visual Mentek, and we will calculate the pH. So let's see. So I have added the component H plus as 1, sodium as 5 and carbonate as 3, and then I have. So was I not audible?
Ah, yes, yes, it is audible. Now it is audible.
So what we have done is that we have find the total concentration of sodium, total concentration of H plus and total concentration of carbonate. We will just put these concentration of the components in the Visual Mentek. So these are the concentration. H plus is 1, Na plus is 5 and CO3 2 minus is 3, and I have run the Mentek. So this is the final result which I am getting. The pH is around 10.342. So I have not added the CO2. The system I have kept is closed. So the pH which I am getting is 10.342. Now we will consider the case when the system is open. So when the system will be open, we will have to add the gases which is open to the system. So we have been given that CO2 is the gas. So we will go to the section gases. Then we will specify the CO2 partial pressure. Like we have been given that the CO2 partial pressure is
3.8.
3.8 into 10 raised power minus 3.
Right.
So we can see that we can mention the atmospheric CO2 pressure is given as 3.8 into 10 power minus 4. But since in the question it is given as 3.8 into 10 power minus 3, so we will multiply it by 10 in the next box. Then we will add, and after adding, we will go back and we will run the midtake, and the final pH which we are getting is 7.901. So the earlier pH was 10.34, and after opening the system it is 7.901. So in the
Right.
open system, this is the pH. In the closed system, this is the pH. And we have to find out the difference of the pH, which is 2.44. So let's see which
Mm.
option is the correct.
Consistent.
So no
Right.
option is given, so we just have to give the value. So 2.44 is the correct answer. So let's move to the last question. So actually this is not question 10, it is question 8 only. So in question 8, if the system is kept open in a room in which the partial pressure of CO2 gas in the room is 3.8 into, we have been given the partial pressure of CO2 gas as 3.8 into 10 raised power A, and the pH of the solution is 4.9. We have to find out the value of A. So again we can solve this question with using visual mintic. So we have been given 5 values. We will put all these 5 values and run the Mintex software individually, and we will see what final pH we are getting, and in the value of A in which the pH will be near to 4.9, that value will be our answer. So let's see. So first we will run for A equals to 0. That means our partial pressure of CO2 gas will be 3.8 atm, or whatever it is atm. So in the gases section, we will specify CO2 is given as 3.8 into 10 raised power 4. So what we have what we have done is that the partial pressure of CO2 can be written as 3.8 into 10 raised power 4, and we are in the option it is said that A equals to 0. So in the second box we will put 10 raised to power 4, because already in the software the partial pressure is 3.8 into 10 raised to power minus 4, and in the question we have been given the partial pressure of CO2 as 3.8 into 10 raised to power 0. So we'll multiply it by 10,000 so that the partial pressure will be 3.8. We will run the software, and the pH which we are getting is 4.907 for A equals to 0. So we will also run for all the other 4 values. So in the second option, A equals to 1, that is partial pressure of CO2 equals to 3.8 into 10. Again in the Mintex software, already the pH is 3.8 into 10 power minus 4, and we have to add 3.8 into 10 raised power 1. So we will add 10 raised power 5 in this, and then we will run the software, and the pH which we are getting is 3.916. So we will run the software for next option, that is C. We have been given the PCO2 is equals to 3.8 into 10 raised to power minus 1. In the software it is 3.8 into 10 raised to power minus 4. So we will multiply it by 1000, and we will run the Mintic, and the pH which we are getting is 5.905. Again for option number D, A is minus 2, that is PCO2 is given as 3.8 into 10 raised per minus 2. In the Mintex software it is 3.8 into 10 per minus 4. So we'll multiply by 100, and finally the pH which we are getting is 6.905. Similarly, we will run for the last option, which is A equals to 2, that is partial pressure of CO2 is 3.8 into 10 raised power 2. So we will multiply the pressure by 10 raised power 6, and finally we will run the software, and we will get the pH as 2.990. So From all these value, by running all these, we got that at A equals to 0, pH is 4.90 plus 4.90 something.
1.902.
907.
907.
So in the question we have been given 4.9. So the correct option is A only. That is at PCO2 equals to 3.8 into 10 raised plus 0, that is 3.8 atm. The pH of the system is 4.9. So A is the correct answer here. So I think this was the last question. So if you have any doubt, you can ask. If you
Madam,
have any
how I,
doubt till now, like in week 1 to 5 questions or assignment, you can ask, or we can end the session here.
madam, my question is, have any other any other anyone classes for lesson?
Sorry.
That means any other any next class which date it will be
Okay.
for?
So the problem solving sessions are on Sunday and Tuesday. On Sunday it is from 3 to 5 p.m. and on Tuesday I think it is from 5 to 7 or 3 to 5 p.m. only. So I
Oh,
have to check it once. Just give me 1 minute.
just, okay.
Okay, on Tuesday it is from 6 to 8 p.m.
Okay, ঠিক আছে, thank you.
Okay. Okay. Thank you so much for joining. Have a nice day.
Thank you very much, madam.
Okay.
Thank you.
Thank you.